In Module 2, we look at the genetic principles driving MateSel. First, to understand this, we need to understand how to make genetic gain. So genetic gain can be calculated very simply. We look at the breeder's equation, which looks at the rate of genetic gain that can be calculated, or what's also called as the response to selection. So genetic gain can be broken down in four very simple and easy to understand terms. So we need to either increase selection intensity or increase selection accuracy, reduce generation interval or increase genetic variation to make genetic gain. So selection intensity is essentially using the best animals, and MateSel can help improve and increase selection intensity by looking at a few factors. So either selecting high performing sires, we can use MateSel to class out low genetic merit animals. We can also use MateSel to purchase semen when we're looking at purchasing external rams or semen to bring into an AI or natural mating program. We can also use MateSel to help underpin AI or ET programs, so both looking at males and females that are used in those ET and AI programs. So we can also use MateSel to increase selection accuracy. And selection accuracy is selecting the best animals with more accuracy. So this can be done through a range of ways on farm, but the best way that MateSel helps us do this is to use ASBVs to help underpin selection decisions or potentially culling decisions as well. Another way MateSel helps make genetic gain is through reducing generation interval, so using those high performing animals earlier in life. So we can use MateSel to help identify any young rams that you might want to look at joining, as well as also classing out older animals. So that can work both with rams as well as ewes. MateSel also helps increase genetic variation, which we need to do to potentially increase the rate of genetic gain. And genetic variation is really important for that long-term breeding program sustainability. So we'll get into this, but MateSel helps increase genetic variation by reducing inbreeding and co-ancestry. So the ultimate aim of sheep breeding is to mate the best to make the best. And we need to think about relationships when we think about identifying the best animals to mate. More often than not, highly related animals, well, they do share genes. Highly related animals share genes in common. And more often than not, high performing animals are often also highly related as well, whether that's through line breeding or just kind of lower or smaller genetic pools. And we know that sometimes mating high performing animals increases the rate of transfer of genes or the relationship between animals. Again, that can be done through line breeding or just smaller genetic pools. But this has a big risk in terms of inbreeding depression and also potential recessive abnormalities. So line breeding is a way to increase your rate of genetic gain, but you have to just be really mindful of the potential risks of inbreeding and how we can manage these as well. And MateSel helps us manage these. So if we take this example here and we have a look at the maternal granddad, and maybe he was a really, really high performing animal, so he was used to breed from quite a lot in the flock. His genes flow through quite quickly, and we end up with cousins of first cousins that are really, really highly related. So while mating the top animals can increase the rate of genetic gain quite quickly, we also have to be really mindful that we don't want to increase the relatedness of the flock too substantially, because that way, if we do that, we tend to bottleneck ourselves and put ourselves in a corner, and there's not a lot of genetic variation. So MateSel helps us ensure that we're making genetic gain whilst also managing genetic diversity. So MateSel helps us mate the best to make the best and ensure long-term sustainability of our breeding program. And MateSel does this two ways. So MateSel looks at relationships between animals, and it looks at putting parameters and weightings on inbreeding. So we want to reduce inbreeding, or at least limit it and make sure that it doesn't get too high. And it also looks at co-ancestry as well. So to understand these two principles that MateSel looks at, we need to understand what inbreeding and co-ancestry are first. So inbreeding is looking at the mating of related individuals and animals. So it is the actual progeny outcome of that particular mating, and inbreeding describes the result. So think about inbreeding as the actual progeny of that particular mating, where co-ancestry is just a description of how genetically related two animals are. So it's the relatedness regardless of whether those two animals are going to be used for mating or not. And it's an indicator of genetic diversity in the next generation. So whilst inbreeding describes the result, co-ancestry describes the potential risk as well. So MateSel looks at both of these in the calculations when it looks at potential progeny outcomes based on the U list and the RAM lists that you input to try and ensure that we have long-term sustainable breeding programs while through managing inbreeding and co-ancestry. So in terms of co-ancestry, I've just got two examples here. This is a really, I guess, good example of high co-ancestry. So remembering that co-ancestry is looking at the relatedness of individuals. So there's less diversity in the population to choose from, and there's potentially that potentially bottlenecks us in the future because there's potentially future diversity in the future. Where this particular population of animals has low co-ancestry, so there's more genetic diversity and greater long-term flexibility. So we're wanting to try and maintain a lower amount of co-ancestry to not essentially limit ourselves to make genetic gain in the future. And an example of inbreeding, so this particular, these two animals are highly related. Let's say they have high co-ancestry and they've gone on to then produce progeny, which is highly inbred because they have a lot of the same genes. Where this example with the red and the blue sheep is a low example of inbreeding because the red and the blue sheep lines, let's say, mix together and they make a purple progeny. So it's a lower inbreeding, there's less related genes in the back pedigree, so those animals are less related, therefore the inbreeding result of the progeny is lower. So just to wrap up, MateSel manages genetic diversity whilst also helping make genetic gain by looking at both co-ancestry and inbreeding. So remembering that co-ancestry controls the overall diversity of the progeny group, so it is looking at how related individual animals are, and we can use the target degrees in MateSel to help control this. And I'll get into that a little bit later when we look at the parameters and inputs that we use to set MateSel up. And MateSel also looks at inbreeding, so it monitors the risk of individual progeny levels. So we don't want inbreeding to get too high in a population because obviously high inbreeding leads to less genetic diversity and more potential abnormalities that come as a result of that. So MateSel wants to manage inbreeding and co-ancestry a little bit differently, but they are not mutually exclusive. So we can control the lever of co-ancestry and then therefore control the lever of inbreeding as well within a population.